GCSE Physics boosters, redshift. Okay, now in a previous video talking about atomic structure, we talked about energy levels and the fact that electrons can only have certain amounts of energy and they can be excited. The electrons jump up to higher energy levels, and then when they fall back down again, they emit photons, which are packets of energy. Now, hydrogen, we can excite hydrogen lots of different ways. One way you can excite hydrogen is you can bash it with electrons, but basically when hydrogen or any other element gets excited, it emits photons, and we call this the emission spectrum of hydrogen, or the emission spectrum of whatever element it is. The important point is that the photons which are emitted can only have certain wavelengths. Okay, so it's a bit like a barcode. If I look at this diagram and I look at these wavelengths, I know that is hydrogen. It's like a signature. It is characteristic of hydrogen. And every element has this barcode, which tells us exactly what element it is, because they all have their own energy levels. Now, if we look at galaxies far away, okay, not Andromeda, much further than Andromeda, galaxies much further away, we notice that the wavelength of the light is bigger than it should be. If you look at the two diagrams below, there's the light from a hydrogen lamp in a laboratory, and then you've got the light from a distant galaxy, and you'll notice that the wavelengths are bigger than they should be. Now, why are the wavelengths bigger? And it's because these galaxies are doing something. They are moving away from us. Okay, you might have heard of something called the Doppler Effect. If an ambulance goes past you, it does something like meow. As it's moving away from you, the wavelength of the sound gets bigger. Okay, the frequency gets lower, the wavelength gets bigger. And why? Because the waves are stretched as the ambulance moves away from you. Now, the wavelength of the light coming from these galaxies has been stretched because the galaxies are moving away from us. Okay, so this is called red shift because red has the biggest wavelength. So all of the colors, all of these lines are shifted towards the red end of the spectrum. But this shows that galaxies are moving away from us. And if you know how much the wavelength has changed, you can work out the velocity that they're moving away. Now this guy, Edwin Hubble, he looked at lots and lots of galaxies, and he looked at the redshift of lots and lots of galaxies, and he discovered a pattern. What Edwin Hubble discovered was very important. This graph. He discovered that the further away the galaxies are, the faster they are moving away from us. Okay? From the amount of redshift, he calculated the velocities of the galaxies, and he plotted a graph, and he showed that they were proportional to each other, that as in the velocity that they are moving away from us, called the recession velocity, is proportional to how far away they are moving away from us. Okay, the galaxies further away are moving away or receding from us faster. And this tells us something very, very important about the universe. Look at these balloons. This balloon is expanding. So this balloon represents the universe, and the little white dots on it represent galaxies. Now, as the universe expands, notice that all of the galaxies are moving away from each other. So Hubble's observations show that the universe is expanding. The universe is getting bigger. All the galaxies in the universe are moving away from each other. They're not just moving away from us. We're not particularly special. They're all moving away from each other. And the further away they are from each other, the faster they move away from each other. So the universe is like a balloon expanding, getting bigger and bigger and bigger. And the spaces between the galaxies is getting bigger and bigger. This must mean that in the past, the universe would have been a lot smaller. It would have been smaller and hotter and denser than it is now. In fact, perhaps it was very, very, very small. At some time in the past, the universe was very small, and then at some point in the past, it started to expand very quickly, like an explosion. And that's what we call the Big Bang. The Big Bang is when the universe started to expand very, very quickly. Okay? And from the graph, because we know how far away these galaxies are and we know how fast they're moving, we can work out when it happened. It happened about 13.8 billion years ago. So 13.8 billion years ago, there was a rapid expansion of the universe called the Big Bang. And the universe is still expanding. So what is the Big Bang? 13.8 billion years ago, the universe started to expand very rapidly. Okay? I'm not saying that the universe was created from nothing. Really, we don't know what happened. All we know is that 13.8 billion years ago, this massive expansion started. The evidence for this, well, the very first evidence for this was Hubble's observation that galaxies are moving away from each other very, very quickly. There has been other evidence as well, something called cosmic microwave background radiation, and there's other evidence as well. And the universe is still expanding now. Yeah, the universe is still getting bigger. And in fact, recently, about 20 years ago, scientists have discovered that the universe is actually expanding faster and faster. And we don't know why. We're not sure why. Logically, it should be slowing down because of gravity, but it isn't. It's expanding faster and faster. So something must be pushing the universe outwards. And they've called it dark energy. Dark energy is something which is pushing the galaxies apart. And scientists know very, very little about it. But we're learning a lot about the universe all of the time. We've got some very clever people working on it. We've got some fantastic telescopes. As I'm making this video, the James Webb telescope has just been launched. Okay, and that's going to find out loads and loads of good stuff about the universe, about the early universe, because the further you look, you are looking back in time, and we're going to see much, much further back in time and see early galaxies and early stars. It's going to be fantastic. Okay, there's a lot about the universe we can't explain, but we're gathering evidence all the time and we are understanding more and more.